Before a single line of code executes, the digital economy relies on a massive, heavy industrial supply chain. Our data actually runs on oil. The crude energy from those ocean transits flows directly into sterile manufacturing cleanrooms. This is where the physical computing hardware that processes our data is actually forged. Once manufactured, that hardware reaches its final destination in hyperscale server farms. These massive warehouses of computation are where the software lives, continuously drawing immense amounts of power. Economists track this relationship using the economic productivity of energy, or EPE. EPE measures the gross domestic product generated per unit of energy consumed. Right now, the AI boom is in a pre-scientific phase, prioritizing rapid adoption and processing speed before figuring out how to operate efficiently. Because processing speed drives early profits, efficiency takes a backseat. The entire digital cloud remains firmly tethered to the physical vulnerabilities and price shocks of the global fossil fuel market. We see exactly how fragile that tether is when military conflicts escalate in the Middle East. Armed forces intercepting commercial shipping lanes immediately destabilize maritime energy transit. The Strait of Hormuz handles 20% of the world's oil and LNG. Threats here instantly add a $14 penalty per barrel. A one-month blockage pushes European natural gas prices from 31 up to 74 euros per megawatt hour. A localized military dispute instantly evaporates the cheap, abundant energy required to train the next generation of artificial intelligence. That energy shockwave travels directly to Asia. Taiwan is the geographic heart of global advanced semiconductor manufacturing, anchored by TSMC. TSMC is the Taiwan Semiconductor Manufacturing Company, the world's largest dedicated independent semiconductor foundry. Taiwan's grid is 99% reliant on imports, drawing 70% of crude oil and 38% of natural gas from the Middle East. With just an 11-day gas reserve against impending summer electricity demand spikes, the threat of power rationing is real. Surging air freight costs and critical neon gas shortages are physically strangling the entire global hardware assembly process. Energy rationing in Taiwan physically chokes off the supply of the advanced chips the entire world needs to run AI. Meanwhile, in the United States, deployed AI models demand massive, heavy electrical infrastructure to keep the servers running. This growth curve projects data from the Union of Concerned Scientists. By 2050, U.S. electricity demand will spike 60 to 80%, driven largely by the massive allocations required for new data centers. Meeting this demand with expensive, volatile fossil fuels breaks the unit economics of training large language models. A large language model is an AI system trained on massive datasets to understand and generate human text. Relying on those fossil fuels also brings compounding liabilities. Increased power plant emissions drive widespread climate damage and massive public health costs. Constrained hardware supply out of Taiwan is colliding with skyrocketing power costs in the US. The foundational math of the AI boom is failing. Technology giants now realize they must urgently decouple their massive infrastructure from volatile fossil fuel markets to survive. They are executing an aggressive pivot towards established clean power, rapidly accelerating the deployment of wind, solar, and battery storage. For stable, around-the-clock baseload power, companies are turning to small modular reactors from developers like Oklo and NuScale. Small modular reactors are advanced, compact nuclear reactors that offer scalable and localized power generation. Securing clean energy has graduated from an optional corporate sustainability goal to a mandatory security requirement. It is the only way to insulate AI operations from geopolitical chaos. To survive this cycle, AI technology has to evolve out of its pre-scientific phase. The underlying hardware and software must be completely redesigned for energy efficiency. The new reality is strict limitation. Future expansion will only happen where sovereign, localized power grids exist, grids entirely immune to foreign conflicts. This is what the permanent physical infrastructure of the digital future looks like. Computing has merged entirely with heavy industry. The AI arms race is a physical race for energy. Can the AI revolution survive the energy crisis?